Hello everyone and welcome to ADS Introduction. So in this tutorial we'll learn how to use ADS to create a workspace and build schematic designs. We will also run simulations with the S parameter simulator. In addition, we are also going to learn how to display data in ADS, import vendor library components in ADS, and lastly, we will learn how to perform optimizations in ADS. So before we continue on, what is ADS at all? It's simply an electronic design software that provides an integrated design environment to designers of RF products. So what we mean is that it is just a software that we use to design RF product, that is radio frequency products. So example of these RF products are, we have power amplifiers, we have low noise amplifiers, we have power dividers, we also have oscillators and etc. So in this session, we are going to learn how to create a workspace and build schematic designs. So let's get started. So in this tutorial, I'll be using ADS 2020, but what you will learn in this video will generally apply to all previous versions of ADS. Right, so in ADS, everything is done with the idea of workspace. Workspace is just folder which contains schematic, working library, layout, and data display. So to create this workspace is pretty simple. So first what you do is that you click on File up here, you go to New, then Workspace. So as I said earlier, I said workspace contains library, schematic, layout, symbols, and all that. But before they will be active, you have to create a workspace. So now you can see that they are all disabled. So to make all these active, we will have to create a workspace. So you click on Workspace. If you really want to know more about Workspace, as a beginner, just click on what is Workspace down here and you find answers to whatever you need. And this is more useful for someone new to this software. As we move on, we will get to know all these and how to use them. So let's proceed. So you would like to give your workspace a name, maybe Jakoma, and you can define the directory path where you would like to save your work. So I'll create this one in, let me say, desktop. Select the folder. Right, so once we've got a workspace in ADS, we have a folder view which you can see over here, and if I click on library view, you see the library which got created by my workspace has the same name as my workspace as Jakoma work. Now for me to start and design in ADS, I need to create a cell, and once this option comes, I either change the name of the cell or I maintain it depending on how I want to name it. So let's maintain the name as cell 1. We click on create schematic. So the moment you click on that, you see that a new interface pops up, and this is where you can insert your component and start building your schematic. So for example, I can pick an inductor over here and place it. I can pick a resistor over here and place it. I can pick a capacitor here. Right after everything, I can pick a wire from this and join them like this, like this. So the cell is where you insert components and start building your schematic. Similarly, you can click on layout and create a layout cell. And in creating a layout, it becomes imperative to select the particular unit you want to work in. For example, let's see, we have a PCB technology, we have millimeter layout resolution. So whatever you want to, just click it here. You see that it will be created right here. We'll talk about layout more in my subsequent videos, right? So, but I just want to show you how the layout also looks like. So I'm going to design a Wilkinson power divider with a design frequency of 3 GHz as an example, so that we will learn how to pick up components and join or connect wires to them to form schematic. So in my design example, we are going to design a Wilkinson power divider at 3 GHz. So the design frequency, as you can see, equals 3 GHz, and capacitor 1 and 2 should be 0.7 picofarads. Inductor 2 and 3 should be 3.75 nanohenry, and L1, that is inductor 1, should be 1.8 nanohenry, and my resistor will be equal to 100 ohms. Therefore, any arbitrary impedance, that is Z0, otherwise the characteristic impedance, should be equal to 50 ohms. So let's start our design. So as I said earlier, in order to use ADS, you would have to create a workspace. And so with this example, we are going to name this Wilkinson. So we will create a workspace. After that, you will create a cell. That is where you will design your schematic. So for a Wilkinson power divider, we will need capacitors, that is 1 and 2. I'm also going to need an inductor. Pressing Ctrl R rotates this element over here. So I'll just place it over here. Inductor here. And I'll pick up a resistor from the components library. Place it over here. And I'll start connecting my wires. So now what I will do is that I'll pick up my wires and connect these wires. With ground. So I'm going to ground this side. Put a ground here. I'll rotate this using Ctrl R. So I'll terminate them with term over here. So you search for term up here, click on it, you put 1 here, 1 up here, put the last one up here. Now place our grounds. We attach them to our term. Specifications were that L1 would be 1.87 nanohenry, so you change it, and capacitor 1 and 2 will be 0.75 picofarads. Same thing over here, 0.75 picofarad. L2 and L3 we are 3.75. Same thing over here, 3.75. The resistor was 100 ohms, and our characteristic impedance, that is Z0, was 50 ohms, and 50 ohms over here. So using the lamped component, that is inductor, capacitor, and resistors, this is how you can design a Wilkinson power divider. Well, thank you for watching. Look forward to another tutorial video on running simulations. Bye for now.